Across the stillness of the universe, there are moments when silence itself feels alive, when the void, usually indifferent and vast beyond comprehension, seems to lean closer, as if to whisper something ancient and strange into the ears of those who dare to listen. This is one of those moments. Tonight our gaze turns toward a visitor from the dark between stars, a traveler that has crossed the boundaries of the imaginable to enter our solar system. It has been named 3A Atlas, and its arrival has shaken the confidence of science itself. At first glance, it seemed like nothing extraordinary. Another faint glimmer on the edge of detection, another ice-bound relic from the cold outskirts of the Milky Way. Astronomers have seen such things before. Objects wandering through the solar neighborhood, briefly catching the light of the sun before fading again into the abyss. Yet something about this one felt different from the start. Perhaps it was the precision of its path, the sharpness of its signal, the way it seemed to glide rather than fall. In those first few hours after its detection, most thought it a minor discovery, a footnote in the growing catalogue of interstellar curiosities. But within days, that casual certainty began to unravel. You see, the universe rarely grants us surprises without a price. When the first data from the Pan-STARRS telescope arrived, it told a story that should have been impossible. The object's motion was wrong, subtly, delicately wrong, but unmistakably so. It drifted where gravity should have accelerated it. It shimmered with spectral hues that no known chemical process could explain. The numbers whispered of something deliberate, as though the cosmos itself had paused its rhythm for a brief, deliberate gesture. And as those numbers traveled from observatories in Chile and Hawaii to the quiet analysis rooms of NASA and the European Southern Observatory, the whisper became a question too bold to ignore. What if this object was not merely falling through the heavens, but choosing its path? In the language of physics, that question borders on heresy. The universe, after all, is supposed to obey laws, clean, predictable, immutable laws that describe every motion from the smallest dust grain to the largest galaxy. But 3A Atlas did not seem to agree. Its orbit curved not by gravitational pull, but by something else, something unseen and perhaps intentional. And so, within the domes of high-altitude telescopes and the glass walls of space agencies, unease began to grow. Engineers recalibrated instruments, data analysts rechecked their algorithms. Nothing changed. The numbers remained defiant. It was as if the visitor from beyond had noticed us noticing it. By the time radar arrays confirmed its deceleration, the whispers had spread far beyond academic circles. A comet that slows down is not a comet at all. Natural bodies do not decide when to brake. They do not adjust their speed in rhythmic pulses, and yet that was precisely what the instruments were showing, a measured, continuous, and deliberate change in velocity, synchronized with its rotation. To some, this was the most thrilling discovery in generations. To others, it was an omen. In science, awe and fear often share the same breath. The notion that a non-terrestrial object could exhibit self-control, no matter how faint, transforms our understanding of what the universe can contain. Could it be a mechanism, an ancient probe adrift for eons, still following instructions from a long-dead civilization? Or could it be something even stranger, something that was never built but born, an intelligence that does not live in flesh or metal but in motion and light? Such thoughts would have been unthinkable a decade ago. Yet tonight, as telescopes align across continents to trace the glow of this object, no one can quite banish the unease. Even the skeptics feel it, the subtle shiver of recognition that something extraordinary is unfolding before our eyes. The first interstellar object, Oumuamua, had already tested our imagination. The second, Borisov, restored our comfort by behaving like a comet should. But this is something else entirely. 3A Atlas defies categories, refuses simplifications, and mocks our attempts to define it. It decelerates when it should accelerate. It turns with impossible precision. It gleams in shades of emerald and silver that shift as though aware of their observers. And in the midst of this mystery, one phrase has begun to circulate among astronomers: motion inconsistent with natural processes. Those 5 words carry the weight of revelation. They mark the boundary where curiosity ends and wonder begins. Perhaps this is merely an illusion, a data artifact born of human error. Or perhaps, for the first time in our history, we are witnessing the movement of something that was meant to be seen. The cosmos has always been our mirror, reflecting not only the light of distant suns, but the limits of our understanding. And now, as this city-sized enigma glides silently through the dark, we are left to ask the oldest question of all: are we truly alone, or have we just been noticed? When the announcement first appeared on NASA's internal feeds, it carried the usual tone of procedural calm. A new interstellar object, catalogued as 3I Atlas, had been confirmed through multiple independent observatories. It was the third of its kind ever detected, and at first the discovery seemed destined for the quiet corners of astronomy. Important, yes, but not revolutionary. In the sterile glow of data terminals across the world, scientists logged its coordinates, calculated its velocity, and prepared to move on. Yet within hours, something began to trouble the equations. 3I Atlas was not following the rules. Its initial trajectory, as observed by the Pan-STARRS survey in Hawaii, indicated a hyperbolic path, precisely what one would expect from an object entering our solar system from interstellar space. But as days passed and new measurements arrived from the Atacama Desert in Chile and from NASA's Goldstone radar network, the numbers started to drift. The arc of its motion began to bend ever so slightly against the predictions. A deceleration appeared, so minute it could have been dismissed as an error until it persisted. It was systematic, continuous, measurable to the 5th decimal. No comet behaves this way. Comets are slaves to sunlight. As they near the sun, solar radiation vaporizes their icy nuclei, creating jets that act like thrusters, pushing them outward. This phenomenon always causes acceleration, never the opposite. But Atlas was doing the reverse. It was slowing down. The deceleration matched its rotation period, forming rhythmic pulses that hinted at something more than chaos, something like control. NASA's Jet Propulsion Laboratory cross-referenced the data, suspecting a sensor anomaly. Yet when the same pattern emerged in readings from the European Space Agency's Gaia mission and the Hubble Space Telescope, doubt began to fracture into disbelief. By late August, internal memoranda grew cautious. Phrases like non-gravitational acceleration and motion inconsistent with known natural processes began to appear in official documents. In the lexicon of physics, such terms are not used lightly. They mark the moment when nature's simplicity begins to erode. The data revealed a precise modulation of speed. Atlas adjusted its velocity by a fraction of a kilometer per second in timed bursts synchronized with its rotation. Imagine a colossal stone, 20 kilometers wide, gently tapping the brakes every few minutes as it spins through the void. There is no known mechanism in the natural universe capable of doing this. Theorists scrambled to explain it. Some proposed sublimation from volatile gases trapped beneath the surface, escaping in regular intervals. Others speculated that solar-wind interactions might produce a pseudo-thrust effect. Yet each theory failed when tested against the numbers. The pulses were too consistent, too deliberate. Cometary outgassing is chaotic. It sputters. It varies with temperature and solar proximity. But Atlas was steady, almost mechanical. Then came the most disturbing revelation. When radar imaging was refined using interferometric data from multiple observatories, the object's density could be calculated through its albedo and rotational stability. The result defied comprehension. For an object of its size, its mass was impossibly low, less than 1/10 that of water. It should have disintegrated under its own rotation. And yet, Atlas spun with flawless equilibrium, its axis unwavering, its orientation fixed to the thousandth of a degree. The only way a hollow shell could maintain such stability was if it were built to do so. That word, built, was never meant to appear in scientific discourse about a comet. But in private communications between research teams, it began to surface. Harvard astrophysicist Avi Loeb, already known for his daring hypotheses about the first interstellar visitor, Oumuamua, wrote in a confidential draft that later leaked to the press. Either 3A Atlas is composed of material beyond current material science, or it was deliberately constructed for flight. It was not a statement of belief, but of necessity. When observation contradicts all known physics, imagination becomes a form of evidence. The James Webb Space Telescope soon joined the investigation. Its instruments, designed to read the faintest whispers of light, turned toward Atlas and found something stranger still. Instead of the spectral fingerprints of frozen gases, carbon dioxide, methane, ammonia, it recorded near-perfect reflectivity at specific wavelengths, suggesting a surface of crystalline uniformity. In the infrared band, where heat signatures reveal composition, Atlas appeared nearly invisible. It did not emit heat like rock or ice should. Instead, it reflected energy with mirror-like precision, as if wrapped in a material engineered to repel radiation. To call this unusual would be an understatement. In nature, such perfection does not exist. And then, as if to underline the enigma, a faint green glow began to envelop the object. It was first noticed through Chile's Very Large Telescope, then confirmed independently by Gemini North in Hawaii. The glow pulsed in a steady rhythm, once every 22 minutes. Spectroscopic analysis identified the emission line at 497 nanometers, too precise to be a coincidence. Traditionally, green glows in comets arise from diatomic carbon fluorescing under ultraviolet sunlight, but Atlas showed no trace of carbon chains. The glow was not chemical, it was electromagnetic. NASA's Swift Observatory detected a matching modulation in ultraviolet frequencies, synchronized perfectly with the visible pulses. The implication was staggering. The object was producing coherent, timed emissions, a beacon of light repeating with machine-like precision. The universe had never shown such behavior from a natural source. In leaked internal correspondence, one engineer wrote, "If this is not an instrumentation error, it is a signal." The idea of a signal shook even the most skeptical voices. Was it communication? Navigation? A form of data transmission to stabilize its orientation? Each possibility raised the same forbidden question: intentionality. To accept that this pulse could have purpose was to accept that the object was in some way aware. Meanwhile, something else was happening, something quieter, more human. Inside the control rooms of NASA's Jet Propulsion Laboratory, the European Southern Observatory, and the China National Space Administration, the tone shifted from wonder to unease. Scheduled public data releases began to slow. Then, abruptly, they stopped. Officially, it was due to data verification protocols. Unofficially, whispers spread of a blackout. For nearly 2 weeks following Atlas's close approach to Mars, at just 29 million kilometers, the nearest any interstellar object had come to a planet, no data emerged. Not a single image, not a single telemetry line. Instruments had functioned perfectly, yet the information vanished into silence. When the data finally resurfaced, it came with heavy redactions. What little remained suggested phenomena unseen before. Fluctuations in magnetic fields, sudden microbursts of radiation, and an unexplained resonance detected by the Mars Reconnaissance Orbiter's high-frequency sensors. The European Space Agency's Mars Express recorded a similar oscillation, a faint hum that rose and fell with mathematical precision. It was as though Atlas had sung a vibration through the electromagnetic spectrum, brief and exact, before fading into stillness. At that moment, astronomers began to notice another pattern, one hidden not in the data of a single object, but across time. The trajectory of Atlas was eerily aligned with those of its predecessors, Oumuamua in 2017 and Borisov in 2019. Each of them, though separated by years and distance, had entered the solar system along a corridor just 5 degrees wide. Statistically, the odds of 3 independent interstellar visitors sharing such an inclination were less than 2%. To astrophysicists, coincidence no longer felt sufficient. It was Loeb's Galileo project that first articulated the idea that chilled many to silence. These were not accidents of celestial dynamics. They were waypoints, a pattern of approach that hinted at deliberate mapping, a survey perhaps of the inner system. Each object carried an anomaly. Oumuamua's acceleration, Borisov's ionized tail, and now Atlas's deceleration. Different behaviors, yet connected through geometry. If nature does not improvise, then perhaps something was composing. And yet, what purpose could lie behind such orchestration? Some theorists propose the concept of autonomous interstellar probes, self-replicating machines dispatched by an ancient civilization spreading silently through the galaxy, cataloging habitable worlds. Others countered that such speculation strayed too far from evidence, but evidence itself had grown stranger. The rhythmic light pulses, the hollow structure, the non-gravitational motion, all pointed toward a system operating under principles unknown to human science. Perhaps, some suggested, Atlas was testing the boundaries of our observation, gauging our awareness. It had decelerated just enough to be noticed, pulsed just enough to be recorded, and then turned silent as instruments reached peak sensitivity. It behaved like a presence aware of being watched. On the night of October 3rd, when Atlas reached its closest point to Mars, observatories across Earth trained every available lens toward it. In those brief hours, telescopes captured something haunting, shifts of light rippling across its surface, geometric patterns that appeared and vanished like reflections on liquid metal. One image, though blurred by distance, showed a faint lattice, an angular structure that could not have been formed by natural fracture. Some dismissed it as pixel noise, others as interference. But those who saw the unprocessed frames privately admitted that it resembled symmetry. The event now occupies a unique place in the timeline of science, a moment when mathematics failed to contain the universe. The visitor's deceleration, its spectral anomalies, and the green halo of electromagnetic containment together form a trinity of impossibilities. If the forces acting upon Atlas are not external, they must be internal. If they are internal, they must be controlled. And so, behind the guarded walls of research institutions, a new hypothesis began to take shape. A whisper of an idea that humanity is not merely witnessing the drift of interstellar debris, but the slow, methodical entrance of an artifact. A construct forged in the black between suns, older than our species, still functioning, still obeying a mission written in a language we cannot yet read. 12 days from now, 3 Atlas will slip behind the sun, vanishing from our instruments for nearly 3 weeks. When it emerges again, its new trajectory will tell us everything. If it continues outward, it will rejoin the endless stream of cosmic wanderers, and skepticism will be our comfort once more. But if it slows again, if it anchors itself into a stable orbit between Mars and Jupiter, then the story of Atlas will no longer belong to astronomy. It will belong to history. For now, the data remains incomplete, the silence deafening, the questions unanswerable. Yet in the quiet between transmissions, one truth lingers, a truth as old as curiosity itself. Somewhere in the dark, something is moving with purpose. something that may have been waiting for us to look up long enough, to listen carefully enough, to finally hear it whisper back. Long before the word Atlas became the center of cosmic speculation, it had been little more than a sequence of pixels on a telescope's array. And yet now, as the world's observatories wait for it to emerge from behind the sun, its name carries a gravity far beyond its physical mass. It is no longer just a celestial object, but a mirror reflecting our deepest hopes and oldest fears. If the first two parts of this story have been about the evidence, the mathematics, the spectra, the trajectories, this part belongs to something larger. It belongs to the people behind the instruments, the history of the machines that made this discovery possible, and the centuries of longing that have led humanity to this moment in the dark. At the European Southern Observatory in Chile, a small team of astronomers still works long into the desert night. Their domes gleam against the cold sky, silver eyes open to the void. Among them is Dr. Elena Rojas, the first to detect the oscillations in Atlas's light signature. She is not one of the famous names of science, not a media figure or a laureate, but a quiet observer whose career has been defined by patience. She remembers the night the data first arrived, the faint tremor of repetition in the light curve that no random process should have produced. She thought it was an error in calibration, perhaps dust in the mirror or interference from the atmosphere. But as the pattern repeated, 22 minutes, 22 again, unwavering, she felt the kind of stillness that only discovery can bring. It was as if something out there was keeping time, she said later in a rare interview. Not chaos, but intention. For scientists like Rojas, the mystery of 3I Atlas is not merely a question of physics. It is a challenge to the very boundaries of knowledge. Across the ocean, in Cambridge, Massachusetts, another figure has been equally consumed by the enigma. Professor Avi Loeb, whose earlier theories about Oumuamua had once drawn both admiration and controversy, now finds himself again at the edge of what science dares to say aloud. In his office, lined with star charts and stacks of equations, Loeb describes Atlas not as an anomaly, but as a messenger. If something can travel between stars and adjust its trajectory, he told his colleagues, then it carries information, not just about the cosmos, but about possibility itself. The instruments that brought these revelations to life have their own quiet histories. The James Webb Space Telescope, orbiting far beyond the interference of Earth's atmosphere, was designed to look backward in time, to see the first galaxies forming in the dawn of creation. It was never meant to find something that might be looking back. Its gold-plated mirrors, polished to atomic precision, have now captured reflections that hint at geometry where none should exist. Beneath those reflections lies a story that stretches back to the dawn of human curiosity, to Galileo's first telescope, to the dreams of Kepler, to the fragile glass lenses that once showed us the moons of Jupiter and convinced us that the heavens were not immutable. In a sense, Atlas is their legacy made visible, the culmination of centuries of asking questions too large for their time. And as with every great discovery, the response of humanity reveals as much about ourselves as about the universe. Some react with disbelief, others with wonder. Philosophers speak of a new Copernican moment, when the center of our understanding shifts again, and we must face the possibility that intelligence is not unique to Earth. Engineers study the data, searching for patterns that might one day teach us to move through the stars with equal grace. For the dreamers, it is proof that the silence between worlds may not be empty after all. But to those who have spent their lives in the precision of measurement, there is a different kind of beauty in this mystery, the beauty of limits being broken. The equations that once described the universe now tremble, not from error, but from expansion. When we speak of Atlas as unnatural, What we truly mean is that it reveals how narrow our definition of nature has been. Perhaps its motion is not the violation of physical law, but the demonstration of laws we have yet to discover. The very act of its deceleration, so gentle and controlled, could be the fingerprint of physics unimagined, fields that bend inertia, materials that sing to gravity. There is something profoundly human about that thought. Every great scientific revolution has begun with an observation that did not fit. The orbit of Mercury defied Newton until Einstein explained it. The ultraviolet catastrophe mocked classical physics until Planck discovered quantum mechanics. Now, the hollow, weightless body of 3E Atlas may become the next riddle that reshapes our understanding of reality. And yet, for all its vast implications, the image that stays with us is simple: a single, gleaming shape gliding through the blackness, turning with impossible precision, a motion so quiet it feels like thought. When it emerges from behind the sun, it will be followed by every eye humanity can turn toward the heavens. The James Webb will track its thermal signature. The Hubble will record its reflected light. Radio telescopes from the Atacama to Canberra will listen for the rhythm of its pulse. Somewhere deep in NASA's control rooms, algorithms are already waiting, ready to catch the first return of its signal. The predictions vary. Some believe it will continue outward, vanishing into the cold of interstellar space once more. Others are convinced it will slow again, perhaps settling into a stable orbit between Mars and Jupiter. A new satellite, an artificial moon, born not of our world. And if that happens, the implications are endless. Astronomers would have the first opportunity in history to study, up close, a structure not born of nature. Engineers dream of future missions that might approach it, probe it, perhaps even touch its surface. Imagine a spacecraft approaching that green haloed colossus, cameras trembling as they reveal the patterns of its skin, the lattice work of materials unknown to our periodic table. Imagine standing on a deck of some future vessel, watching sunlight slide across a hull that might have traveled for 1 billion years. In moments like this, science and imagination are no longer separate. They are the same act of reaching outward. Every question about Atlas is also a question about ourselves. How far can intelligence go? How long can purpose endure? And what becomes of knowledge once it transcends the need for words? The idea that we may not be the first to ask these questions is both humbling and exhilarating. For all the speculation, there is still one undeniable truth. Whatever Atlas is, comet, construct, or something in between, it has reminded humanity of its own wonder. In laboratories, observatories, and classrooms, people are once again speaking of the universe not as a cold machine, but as a living mystery. Students who once memorized formulas now look at the stars with the same awe that once drove explorers across oceans. The story of Atlas has already changed us, even before its ending is known. If it is an artifact, then it carries the voice of a civilization older than our species, whispering across the void. If it is natural, then it reveals that the cosmos itself is capable of building wonders beyond imagination. Either way, it tells us that the universe is more complex, more alive, and more patient than we ever dared believe. So we wait. We watch the sun's bright corona, knowing that beyond that curtain of light, something vast is moving, a silent traveler that has crossed the distances between stars to reach us. Perhaps it will pass and never return. Perhaps it will stay, orbiting quietly for centuries, a monument to a moment when humanity first realized that the sky above was not empty. In the end, that is the legacy of 3E Atlas. Not the data, not the equations, but the transformation of our perspective. It has turned our instruments outward, yes, but it has also turned our imagination inward, forcing us to see ourselves as part of a story far older than civilization, far grander than Earth. The desert domes of Chile, the frozen peaks of Hawaii, the gleaming mirrors of space, All now share a single question whispered beneath their breath. If we have been found, what happens next? No one can say, but for the first time in human history, we may soon have an answer. And when it comes, whether in light or silence, it will echo across the centuries as the night when the universe spoke, and we listened.